Welcome again. Today I'll show you how to solve a linear programming problem using the graphical solution. On page 61 of your textbook, question number 1, the problem deals with a lady who has to bake cakes or bread for a PTA function. Now, as you read through the text and look at the question, we must determine 4 things which are important in every linear programming question. These 4 things are your decision variables, your objective function, your constraints, and 4, your non-negativity constraints. Okay. The first most important thing to do is to determine what your decision variables are. To determine your decision variables, a few keywords are important. As you scan the question, look for the following terms. How many? If you look at the last line of the question, it says, Mary wants to decide how many cakes and loaves of bread she should make. In any linear programming question, this how many or what combination, these are the key words to look for when determining what your decision variables are. In this case, we want to decide how many cakes and how many loaves of bread we should make. So in this case, our decision variables are loaf of bread and cake. To make it easy, we will say let C equal number of cakes to produce, and let B equal number of loaves of bread to produce. Now, once we know what our decision variables are, our objective function will be in terms of our decision variables. In this case, what we are trying to achieve is we want to make as much money for the PTA as possible. So our objective in this case, in determining how many loaves of bread to make and how many cakes, is to achieve maximum profit or maximum sales. In this case here, our objective function is maximum profit. It will be in terms of your decision variables. So it will be something, some coefficient C plus something B will be your objective function. Now, for every cake that is sold, the question says we will make $10. For every loaf of bread that is sold, we will make $6. So in this case here, our maximum profit will be $10 per cake and $6 per loaf of bread. So our objective function is in terms of how many cakes, how many bread, and how much profit you make on the individual items. For example, if 10 cakes are sold, you'll make 10 times 10, which is $100 profit. If 10 loaves of bread are sold, you make 6 times 10, which is $60. if, for instance, 10 bread and 10 cakes are sold, you'll make 10 by 10 and 6 by 10, which is 100 plus 60, $160 profit. Now, we have our decision variables, we have our objective function. Our next step is constraints. Constraints deal with resources. Now, in this case here, we know in order to make the loaf of bread or the cake, she must use flour and she needs time to bake. So two constraints here are in terms of flour and baking time. Now again, your constraints are going to be in terms of C and B. Something C plus something B. Okay. In flour, how many cups does it take to make a cake? It says a cake requires 3 cups of flour. So in this case here, your coefficient for C, for flour, is 3. It takes 3 cups of cake, 3 cups of flour to make a cake. Now, how much cups of flour does it take to make a bread? They say that it takes 8 cups to make a loaf of bread. So the 8 comes here. 8 cups to make a loaf of bread. Now, they also tell you that Mary has 20 cups of bread. So your constraint is that you need to make either cakes or bread, and this amount of flour is what you have available, 20 cups. It takes 3 cups for cake, 8 cups for bread, and you have a total of 20. You have up to 20 cups to use. You can use less, but you cannot use more. In this case here, this is where the less than or equal to sign comes in, because you have up to 20 cups to use of bread available. Same thing in baking time. They said it takes 45 minutes to make a cake and 30 minutes to make a bread. Now, they said that the total time available is 3 hours. Now, 3 hours is 3 times 60. 3 hours times 60 minutes, and that is 180 minutes. So you have a total of 180 minutes available. So we have here 180 minutes. This is cups. Now, these 3 steps are the most important steps. You must determine your decision variables, your objective function, and your constraints. Now, the non-negativity constraint, all this is saying is that you cannot make a negative cake or a negative bread. You must produce something or nothing, but you cannot produce minus something. This is very important. B and C must be greater than or equal to 0. You can produce 0, or you can produce 1 or 2, but you cannot produce -1 or -2. This is very important. This is the first step of your linear programming model. Now, from here, once you have this step, the next step is to draw a graph. To draw the graph, we'll be drawing the graph of your constraints. That is our next step.